positive. So this is, and we did not touch. So this is an example of induction. At the end of the story, the object that's being charged is one charge, and the object that's doing the charge is the other. And the way that happens is these are being chased away. So the negatives were chased down to here and then into the finger, leaving a positive charge. So induction does not touch, but it chases away. And conduction does touch, and we have the same sign jumping across the conductor. So this is induction. No touch, opposite signs at the end of the story. Conduction, touch, and we have the same signs at the end of the story. So make sure that's reflected in your notes. It's one of those major points.
That's wrong.
Yeah. Okay. All right. Let's go ahead then and have a formula before we all have formula fits. That's when you get upset for not having a formula, right?
Should we do another video?
So, right,
Should
you
we
ready?
do another one?
Was that not one?
No, that was on.
Okay.
So should we do another one? Keep going?
Yeah, well, how long has it been? Do you have any idea?
I don't know.
What do you think? Maybe 5-10 minutes?
Probably. We probably do the formula and then
All right, I'll do the formula.
we'll be fine. We'll find out.
All right. I was wondering if there was a formula that represented the strength of the force caused by these things. We're studying electrostatic force, so there must be. So we're going to look at force, electrostatic. So this is electrostatic. Static means still. Force. So I'm going to indicate it by a large F for force and a small e for the electrostatic part. And there is a formula. It is K, new constant, Q1, Q2 over R squared. So that's our main player for this mod. Let me explain the parts. K is a constant, and that is Coulomb's constant. Coulomb was someone who did a lot of work in this area, and so we named the constant after him. Does anyone remember the gravitational constant when we did that? Not the 9.8, but that big G that we had in a formula once. Anyone remember what it was? All right.
Something?
What was it?
1 point, 1 something? Or was it 2 something? I don't know.
All right, well, we'll look that up. Coulomb constant, and that is, I wanted to compare it to gravity, 9.0 times 10 to the 9th. So that's pretty nice. 9.0 times 10 to the 9th, you got 2 9s going. Q1 is the amount of charge in the first particle, and charge is going to be rated in coulombs. So they'll be in C's and
columns or coulombs?
coulombs. I looked up how it's supposed to be pronounced. Have you heard it Coulomb?
No, but it looks like column.
Yeah, I looked it up and it said Coulomb. Coulomb. So I'll check that again. I'd always said it columns, and I knew that was wrong.
Amount of charge in the first one. Says some of the word. I think it was something with C. I think something with C.
Coulomb.
P-Max spot.
All right, ready? Listen. Say it.
Coulomb.
Say it.
Coulomb.
Coulomb. All right. Not very loud. Coulomb.
Here, guys, please.
All right.
It's a Coulomb.
All right. We have a Coulomb. The charge is in coulombs, and that's a C. A C. 1 Coulomb is very, very large. So a lot of times our charges will be in millicoulombs, even microcoulombs. So A lot of times you'll see this symbol
MC.
and little MC. So sometimes check your problem because you want to work you want to work in coulombs to get the right result for
Do we
the
have to
right
convert
unit
it?
over here. Pardon?
Are we ever gonna have to convert this?
From millis, yeah. But from millicoulombs to coulombs, you just move the decimal over 3 because milli means 1,000, so that's 3 decimals. So it's a quick conversion.
Wow.
All right. So the charge, this is the charge of the first particle. This is the charge of the second. They are both in coulombs. All right. So whenever I say coulomb, you say coulomb. All right.
You're never gonna do this.
All right, so R is like it normally is the distance. Between the two, notice it is squared. So if a student makes a mistake, it's usually right there forgetting to square it, or a teacher. So keep your eye on me. So if you use coulombs, say it.
Coulomb.
If you use coulombs and meters, and actually K has a unit which I never remember. It's a Newton meter squared per coulomb squared.
Coulomb.
Alright.
What's her name? Coulomb.
If you use all the proper units, and I will always give you K in the correct unit, then guess what the unit for force will be? What is force always, everyone? Newtons, right. So we'll have newtons over here if we use coulombs.
Coulombs.
Alright, so, alright, if we use millicoulombs, we have to change it to coulombs.
Coulombs.
Alright, thank you. Alright, first problem. So we don't have a formula fixed. Time to go.
Literally.
7,
Every week this happens.
8:35. We got a good long time. Alright.
So
Let's do one problem here, and then I think you can do a couple, and that's it. And then we'll do review. I keep wanting to do review. Alright.
Yeah. Same. It's really bad because it's on my phone.
Well, yeah, but then I always forget to turn it on going places that we need to see all for. I don't know if it's going to
No, I only turn it on like when I'm waiting for someone to text me.
Yeah, I'll do that.
I'll ignore people and then I'm waiting for the one person to text me.
Alright. This formula deals with the force between two charged particles, so that's what I'm going to ask you to calculate. So the force, I'll do one and then you do one. Suppose we have a plus, charges are positive or negative, so this first particle is 3.0 mini coulomb. Coulombs. Charge is placed 2.2, thank you,
You don't listen to that.
2.2 meters from another charged particle, and that's minus 2.0 millicoulombs.
Coulombs.
Thank you. And I want you to find the electrostatic force in between these two particles. Find, I'll call it force electrostatic, F sub E. So, we're in millicoulombs,
Coulomb.
and we have to change it to
Alright, you're done.
coulombs.
You're done.
You're completely done.
We have to change from milli to regular coulombs.
Coulomb.
Coulombs.
There we go.
So take this decimal and move it 3 to the left. So this will be 0.003 coulombs. This one will be 0.002 coulombs. This is what the number is when you put it in the formula. All right.
Why is he done?
Let me peek at your answer by putting
Wait, I'm
everything
still
in.
writing the problem down.
Right, reason.
So do you make it negative?
All right, we'll discuss that. You can put it in as negative.
2 seconds.
Wait, so you do have to
Oh.
convert?
Oh.
What?
so
What?
you
No, I
didn't
didn't say it. I didn't say it.
I heard you.
I didn't. You heard
Don't
wrong.
lie.
You heard wrong.
You heard wrong. Wrong.
This is gonna end. That was a
Did
really
we
good.
start over yet? Zach?
Be a
We
lawyer.
didn't start over yet, did we? All right, let's do that
Parents should be
now.
lawyers.
Oh, yeah.